Ashlyn here at the Children's Science Center lab, bringing you a video inside the lab. We want to take you through some of the exhibits we have here. So today I have this wall behind me that we call the chain reaction wall. So it uses something called a chain reaction. Now, what is a chain reaction? Picture a set of dominoes. When one domino falls over, and knocks the other domino over too. We call that a chain reaction because it's a chain of items reacting because of something else. So this is a little bit like that. This wall is also all about energy. Now we have some energy in our bodies, right? We use that energy to run around, to play sports, to bike, to play with our friends, and we get that energy from the food that we eat. We also use energy in our houses, right? We use electricity to turn on the lights, electricity to watch TV, electricity to make our fridge and freezer work so we can eat ice cream. And electricity and the energy we have in our bodies are two different types of energy. And this is going to use a type of energy too, specifically kinetic and potential energy. Now, kinetic energy is the energy of motion, of moving. So when you're kicking a soccer ball, when you're running around, when something's spinning, that is kinetic energy. It is moving. Potential energy is something's potential, right? If someone says you have potential, they're saying you could possibly do something, right? Potentially it could rain today. Maybe it could rain today. So potential energy is kind of like the possible energy or stored energy. When you have energy that's waiting, and it wants to burst out, it's potential energy. And as soon as it bursts out and is moving, that is kinetic energy. So for example, if you're shooting a bow and arrow, back here, my energy is potential, it's stored. As soon as I release that bow and arrow and it goes out, that is kinetic energy. It is moving. So let's see if I have some potential and kinetic energy in here, in my wall. So over here, you can see there is a little crank handle. And that is actually a wheel, one of the simple machines we use to move. So there's this wheel and this axle, which is attached to this long thing here in this nice long tube. It might be kind of hard to tell what this is, but it almost looks like a set of stairs, but a set of spiral stairs going around. So this is just an inclined plane or a ramp, just like this. So ramps or inclined planes are like stairs. They help us go up, or like a ramp to help a wheelchair go up, or if you're pushing something really heavy and you need to go up, it's easier to do it on a ramp. Or this is almost like a slide, right? Who likes going down slides? Whee! So ramps will help move things up and down. So this is a ramp, but it's twisted around a rod. So we call that sort of simple machine a screw. Now, typically, screws are used to keep things together, right? You screw something into the wall. There's screws holding some of this together, right? This kind of screw is a moving screw, or we call that an Archimedes screw. A lot of times they're used to get water or rocks up out of the ground. But in this one, it will take these wooden balls up and up and up. They're coming up the side there, if you can see them. So when I spin this, the balls go up. Pretty neat, right? So how do I get the balls in there? So I put them right there. Bling, bling. And then it uses my own energy. So if I'm spinning this for a really long time, do you think my muscles are going to get tired? I might start to sweat, right? So I'm using my energy that's in my body, my muscles from the breakfast I ate this morning, to convert it into energy going in to this tube. So you can see there's actually energy in those little balls right there. What kind of energy is that? Stored in those right there. It's potential energy. It's the energy that's waiting, right? Once they go up and up and up, I'm giving them more and more potential energy. So till the one at the very, very top has the most most potential energy. Wait, why does one at the top have more potential energy than one at the bottom? Now let's test that. I have this ball right here. Let's say it's right here. And I'm going to go like this. I'm going to give it more potential energy. Let me give it even more. Until it's all the way up here. This is its potential energy. It's waiting. And as soon as I drop it, it turns into kinetic energy. So the higher up it is, the more potential energy it has. So the more kinetic energy it will have on the way down. So let's try it out with these ones here. Let's see. Spinning, spinning, spinning. Awesome! It fell out. Oh, wait. Okay. This is more than just using your energy to get the balls to go up. You can see we have all of these things on the wall here, right? This is actually an engineering challenge to try and get one of these balls to get back in here so it can travel along a path and come back. And we're going to use potential and kinetic energy to get it to do that. So let's see, these pieces here are actually magnetic and the wall is magnetic. So I can move them wherever I want. So let's see. The ball falls out here. I'm going to try putting this one here and this one here. And let's see what happens. All right, interesting. It just went that way. Let's see something a little bit different. So this one, it went up and then it didn't quite fit through there. So I'm going to have to redesign. That's something that engineers do. We test something out, we try it, and if it doesn't work, we don't give up, we don't cry, we try again, right? We redesign and then retest. So I did a little bit of redesign here, and let's see what it does now. Awesome, okay, that worked. It went this way. Now let's see if I can get it to connect to here and go up. Let's see if I can get it to go up and off. Let's just see what happens. I've got a lot more I'm going to need to crank up. Oh my goodness! I'm getting so tired. I'm losing so much of my energy. But look, I'm giving this ball so much more potential energy. If I release, and it turns into kinetic energy. Oh, did you see that? It went this way. It went here. And then it stopped. It just went back down. It didn't go up. So it went down because gravity is trying to drag it down, right? If we want it to go up, it needs some more potential energy to go up the ramp and fight the gravity that's bringing it down. So let's say if I move this up, and I move this up, actually if I move this up, and then this up, let's see if I can get it going even faster to get more potential energy, more potential and more kinetic. Oh, it went about halfway up. That was so close. Let's see, maybe I can get even more if I just go straight to trying to go up. So it goes really fast down, and it'll get a lot of energy to try and go up. There, let's see if I can do that. Oh, awesome, it did go up. Okay, so now I want to try and have it go back this way. What should I try? Let's see. Let me put this here, and I'm going to try a spinning thing. Let's try this, let's try this, let's try this. Okay, let's try that. Check that out! So I just need one more piece to get it from here back into the little hole there. So let's try adding a short little piece like this and see if I can get this going. All right. Awesome! Right there. Pretty cool, huh? And I could try to design and redesign. So I may have changed direction one time and spin one time. How do you think I could include more of these spinning objects? Or maybe include all the pieces on the board? or have it change direction 10 times instead of just one time? Let's think about it. So at home, you may not have something like this. We would love for you to come to the lab when you can to try it out. You could also try it with cardboard tubes and a marble and position them to see where the marble can go. But remember, if we lose our energy and go down, it's really hard to get back up, right? We need to build up that potential energy to get that kinetic energy to defy gravity. All right, I'm going to keep playing with this. I hope you enjoyed this inside look at our lab and our chain reaction wall to learn about potential and kinetic energy with me today. Bye!